Hi guys, welcome. This is a video to basically replace the class meeting for Wednesday, March 21st. And so in this brief video I'll talk about a couple of different things. We'll look at proportions in a slightly new way. So recall that when we're talking about proportions or solving them, we have something along the lines of, let's just say 3/5 of all people have some certain characteristic. Well, how many would that be in a group of 200 people? So we've been solving things like this. Now, this can actually be thought of in another way. Now, keep in mind that all the problems that we're dealing with, we need to know 3 out of the 4 components, meaning that we need to know at least one numerator and 2 denominators, or vice versa. So we're always given a ratio of some sort. So let's write this as ratio equals x divided by 200. Or more generally, instead of x over 200, let's think about this as part over whole, or part in the total. The reason I'm using part and total is because total is really talking about a total quantity of something. So we have a ratio. Basically, remember, a ratio can be one of 3 things. It could be a fraction, decimal, or percentage. In this case, it just happens to be a fraction. Now, what we've been doing is we've been multiplying through both sides by, for example, 200 in this case. Using our rules we developed, we found out that we can multiply both sides by 200 and solve for the part. So in the same fashion, we took both sides and we multiplied by the total. So what that gave us is the ratio times the total equals the part. And this is a really important equation because it allows us to be able to really figure things out fairly quickly. So for example, let's take a look at a couple of problems. Now this equation will apply whether this is a percent, decimal, or a fraction. So in the fractional form, typically we do 3 divided by 5 and then multiply it by 200. But if it's already in a percent form, we can work with it as a decimal as well. So let's take a look at an example. So this is an equation that we're going to use based on the old, this is nothing really new here, it's just another way of looking at it. So let's look at it here. Milos attempted 200 baskets, or let's say we're talking about basketball. He successfully made 32% of them. How many is this? So we say that the ratio times the total equals the part. Now, 32% that's 32/100ths. Remember. And what I'm going to try to do is I'm going to leave it as a decimal, so 0.32, because that just is an easier plug-in value. So my ratio is 0.32. That's my known ratio. So the first thing I want to stare for is to determine what is my ratio. Is it a fraction? Is it a decimal? Is it a percentage? Here it's a percentage, but I'm going to plug it in decimal form as my ratio. Now, do I know the total of the part? I know that he attempted 200 baskets. Well, that's the total, right? Because that's how many I attempted. So if I take 32% and I multiply it by 200, except I use it in its decimal form, then I can multiply these two numbers together, and whatever calculator you have, it'll all work just fine. So I'll do 0.32 times 200, and I get 64. So 64 made. 64 are my parts. That's the thing I made out of the total 200. So this just makes it a little bit more convenient to write because I only have to really write 3 things down. Here we're saying in example 2 that the candidate had 65% of a group of people convinced, I should say, or had their votes. The votes of 65% of a group of people. How many is this in a group of 20 people? Okay, so again, when I think about ratio times total equals part. The beauty with the percentages is that we always notice that it just ends up being point and then the percentage. As long as it's 32%, or as long as it's a 2-digit percentage. But we could always divide it by 100 and figure out what it is. So if we do in our calculator 65%, that's our ratio. And we also have a number that says 20 people. Well, 20 people is obviously our total, because not all of those 20 people are going to vote for this candidate. So the total, when we multiply that by 65%, which we keep in mind is 65 over 100, which is 0.65. I can plug in 0.65, multiply it by 20, and that will give me the part, or the number of people who are going to be voting for this guy out of the 20. And that happens to come out to be 13 will vote for him. So notice that all we've done is we've really just manipulated this little way of talking about a proportion, that we have a known ratio. We're going to take that and equate it to a fraction, but instead of working with fractions, I really can just work with multiplication and equate it to the part. Again, this always works because we're still just using our ideas in the correct fashion. So in 128 experimental trials, 62 were successful. What percent is this? Oh, okay, so we don't actually know the ratio. We're not given a ratio. So that means we have to be given a total and a part. In other words, we don't know what percent, we're trying to figure out what percent. So we want to figure out the ratio. 128, well, that's the total number of trials conducted. So we're going to have our ratio, which I'm just going to call it R for short. And my total is 128, and that has to equal the part, which is 62. Okay, well, you know, I really want to know what R is. I really want to know what the ratio is. What percentage is this? This is actually a pretty simple find. This is still an application of our rule number 2, if you recall. If I divide by a number and I multiply by a number, then I recover the original. So if I multiply by 128 and I divide by 128, this is just written another way, and I do it on both sides, that's rule number 1, then I just end up with the original ratio. So I take the rate, I multiply by 128, I divide by 128, I'll end up with the original number. So on this side, 62 divided by 128 will give me 0.48435, and depending on how far we round, let's just say that this is 48/100ths. So in other words, this is going to be 0.48, which is another way of saying this. I'll say that's equal to 48/100ths, which is equal to 48%. So 48% of the trials were considered successful. Now, alternatively, if you wanted to write it this way, you could. It's just all a matter of preference sometimes. So if I wanted to say divide by 128 and then divide by 128, that would be the same thing, and we could say, well, since we multiply by it, we divide by it, we end up canceling those out. So we end up just getting R equals 62 over 128, which is basically the same thing we did here. It's just visually it looks different. You can use whichever. Both of these are just as valid. You can use whichever approach you want. If you want it more in line, you can have it more in line. If you want to have fraction bars, you can have fraction bars. Okay, the next important thing kind of going on with this is this idea of actual change versus relative change. These are important because now you probably remember an actual and a relative amount. Actual amount and a relative amount. So actual change is the amount by which two things are different, or two numbers are different. So this is the amount by which they are actually different. The relative change is relative to the original amount by what percentage what percentage or decimal or fraction did it grow? Or not grow. So grow, or we'll say decay. Decay is a common word to represent something going down versus going up. Growing or falling would work just as well. So let's take a look at a couple of examples. First of all, we'll just define actual change in a very basic way. Actual change is literally the amount by which two things are different. So let's call those things new and old. Well, actual change is how much it is now, the new value, minus what we'll just call the old value. So let's take a look at an example. I'm going to pull up an example here that I have on my desktop. Okay, so here's an example I have. And so we're going to determine the actual change and the percent change of the following quantities. Percent change is really another way of saying relative. We're going to just start going with the actual changes. You paid $20 for a rare baseball card that is now worth $30. Okay, so which one's the old, which one's the new? Well, it was worth this when you bought it. Now the new value is worth $30. So the actual change, I'll just abbreviate it AC, actual change, is equal to the new minus the old, which tells me that the actual change was a positive $10. That means that it grew by $10. Last year's graduating class had 180 students. This year's class size is 225. So the actual change, well, this was the old amount. That's how many students there were. Now, this year, there are 225. So what's the difference? What's actually the numerical difference between those? Well, it's 225 minus 180, which is 45 people. So this, again, represents growth. And invested $300 in energy stock, and now it is worth $540. So it was worth this. There's the old. There's the new. And the actual change is the new minus the old, so 540 minus 300, which is equal to $240. I probably should be putting units on these so we know what we're talking about. And this was $10 as well. Okay, so there's actual change. Now relative change says, hey, you know what? Compare again, this could be called percentage change as well. There are two different names for it, but they mean the same thing. Relative change says, hey, let's compare. Let's create a ratio. Let's compare the actual change, how much it's grown or decreased by, and compare it to the old amount, the old value. So basically, we're saying how much has it grown by? Let's compare that to what it was previously, and that will be our measure of what we'll call relative change. So let's back up here. Actually, I'll pull up these problems again, just so we can now take a look at them again, but now just do the percentage change. So we already did this. What did we come up with? We said actual change for A was 10, 45, and 240. 10, 45, and 240. So this is typically expressed as a percentage. That's why we typically call it a percentage change. So to find the, so again, we call these numbers our old. This is how many, how much or how many there were initially, and then this is what they became later on. So here our relative change, which I'll just abbreviate RC, is going to be our actual, which is 10, divided by our old amount. So we're comparing the amount of growth to the old amount. When we divide these, we actually will divide them. 10 divided by 20, if you do that in your calculator, 10 divided by 20, you get 0.5. Or 0.50 if you'd like. Well, 0.50 is equal to 50 100ths, which really means 50%. So um, this would actually be considered the relative change, the amount of percentage growth. So we can say that there was 50% growth in the value. Similarly, here we can say that our relative change is equal to the actual change, which it grew by 45. Compare that to how many there were. If you grow by this much compared to this amount here, well, what's that going to be? 45 divided by 180 comes out to 0.25. That's 25 100ths, which means 25%. So we can say that the class size grew by 25%. Now keep in mind what 25% means. That means it grew by 25 for every 100 students originally present. So it grew by 25 for every 100 students, i.e. it grew by 45 for the 180 students. So really a relative change is just saying how many it's grown per how many there were. So 45 per every, 25 per every 100. Here again, we'll do relative change equals the actual 240 divided by the original, which is 300. So that means this guy, 240 divided by 300, has actually grown by a total of 0.8, which we can add the 0 after that and say that this is 80% growth in stock value. And we'd be done. So in other words, for every $80, we've grown $80 for every $100 that we originally had in value. And that makes sense because 80 times 3 is 240, 100 times 3 is 300, and so we've basically grown $80 for every 100 that we originally had. This could be probably easily demonstrated by using a little visual. So we had 300, we went to 540. Okay, so that means that if we break this thing up into 100, so our profit, our actual change, so this is the amount one, the old, the new. So there's our old, there's our new, and now let's look at our old and look at our actual change. So our actual change was $240. Well, for every 100, if I break this up into 3 100s, and I break this up into 3 pieces, that means that for every $100 that I started off with, each $100 amount increased by 80. This $100 amount increased by 80. This $100 amount increased by 80. These are all actual changes for each of the old $100 bills. This is just another way to visualize it. And this is what we mean by 80% growth. 80 for every 100 old dollars. So let's take a look at a couple more examples. The next example we'll take a look at deals with the same idea, except the information that we're given, we're kind of needing to determine what is actual change and what is relative change. So you and your colleague are bragging about your respective stock performance. Each of your stocks earned $1,000 last year. Then it slipped out that your original investment was $2,000 while your colleague had invested $20,000 in her stock. So we're going to have an actual change for you and an actual change for your colleague, and I'll label these ACY and ACC. Well, we're told that it actually you both earned $1,000 last year. So there's our actual change. That's how much it grew by. We want to calculate the relative change for each investment. So the relative change for you is going to be your actual change divided by your old. Well, your actual change was a growth of 1,000. What was your old amount? Well, you originally invested 2,000. So 1,000 divided by 2,000, if you do that in your calculator, is going to be 0.5. Whoops, I guess we can calculate that. So 1,000 divided by 2,000 is equal to 0.5. Now that's 0.50, which is the same thing as 50%. So yours grew by 50%. That means yours grew by you gained $50 for every $100 that you invested. That's really, really good. Now for your colleague, however, your colleague invested a lot more money and still only earned 1,000. So their actual change was 1,000, but they invested 20,000. So really, they didn't earn a very big percent. 1,000 divided by 20,000 is 0.05, and 0.05 is only 5% growth. That means for every $100 that person invested, they only grew by $5. Remember, 5% means 5 for every 100. So 5 growth, that's what's on top, for every 100 invested. That's what's on the bottom. So obviously, yours is better. Yours. Bigger percentage growth. So even though the same amount took place, the percentages were different. Your percentage was higher. For every $100 you invested, your return was 50. Let's take a look at one more example here. Let's take a look at one more example to kind of round things out. And again, another very similar problem here. You and your colleague are bragging. Oh, this is the same one. Never mind. Let's skip this one. Let's do a brand new one. We just finished that one. Okay, here's one. So during the first week of classes, campus clubs actively recruit members. The Ultimate Frisbee Club signed up 8 new members, reaching an all-time high membership of 48 students. The Yoga Club also attracted 8 new members and now boasts 18 members. What was the membership of the Ultimate Frisbee Club before recruitment week? Well, now they have 48. Before recruitment week, they had 8 fewer students. So that means they originally had 40 students. Now that's the old amount. That's what we had previous to recruitment week. We want to know now by what percent did the Frisbee Club increase its membership? That's the same thing as relative change. Relatively, how much did it grow? Well, remember, that's how much it actually grew by divided by the old amount. So it actually grew by 8 students. That's how much it went up by compared to its original 40 students in the club. So 8 divided by 40 is equal to 0.2, which is same thing as 0.20, which is the same thing as 20%. So it grew by 20%. What was the membership of the Yoga Club before recruitment week? Well, the recruitment created a club that's now 18 big. But before that, it had 8 fewer students, so it only had 10 students before recruitment week. So that was the old number of students present in that club. By what percentage did this grow? Well, that's a relative change again, and that's actual divided by old. Well, it actually grew by 8 students as well. Like the Frisbee Club, it grew by 8 students, but it only had 10 students to begin. So it actually, relatively to how much it had, grew by a bigger percentage. If you do this in your calculator, you get 0.80, which is 80% growth. Now that's huge. That nearly doubled the number of students in the club. Whereas here, 8 out of 8 compared to the 40 was not as big of a growth. But a good thing they both at least grew a little bit. So we'll stop there. Check out the homework problems. Bring any questions you have the next time we meet. And until then, take care.